Good morning, everybody. Myself Acharya Vishvendra, and today I'll discuss the solution of quiz of the day. This is for class 12th, and the topic is resistance. So, as you can see over here, there is an electrical circuit comprising of two resistances R1 and R2 connected to a battery of voltage V and source here is S, and there is an emitter connecting the system. Now, here the trick is that temperature coefficient for R1 is alpha and R2 is minus alpha, and we have to find effect of increasing temperature on reading of emitter, reading of voltmeter, and reading of voltmeter V2. So if we analyze that if we increase the temperature, then certainly resistance will change. But since these two resistances are in series, so we can say that R equivalent will be R1 plus R2. So on increasing temperature, R1, R2 will change. Let us write that resistances become R1 dash and R2 dash after changing temperature. So R1 dash can be written as R1 1 plus alpha delta T, and R2 dash can be written as R2 1 minus alpha delta T. Here is the trick. So R equivalent will be R1 plus R2 plus alpha delta T into R1 minus R2. Now here in the question there is one important thing also, that R1 is equals to R2 is equals to R initially. So if R1 is equals to R2, so this term will get cancelled out. So we can say that R equivalent will always be equal to R1 plus R2. Hence equivalent resistance of circuit will never change, because one will increase and other will decrease by the same amount. So we can say that I is equals to V by R equivalent. So that will be V upon R1 plus R2, and that will be constant. So this is answer of the first question, that reading of emitter will be constant as there will be no effect on that. Coming to the second question, which is reading of voltmeter V1. So V1 is connected over here. So since the entire circuit is in series, so here current will be I, here also current will be I. We assume that voltmeter are ideal, so infinite resistance they offer. So we can write V1 as I into R1. Now R1 can be written as after increasing temperature, let us say it becomes R1 dash. So it can be written as R1 plus alpha delta T. So certainly you can see that initially delta T is 0. So V1 will be IR, but after increasing temperature, V1 will increase with increasing temperature. This is, we can analyze mathematically. The delta T will be positive, so V1 will be greater than IR. Initially it was IR, so it will increase. Now we know that applying Kirchhoff's law, we can say that V1 plus V2 is equals to V. So V2 is V minus V1. Now on increasing temperature, V1 increases, that means V2 will decrease. So this is the entire solution for the three parts. So as per the first question is concerned, answer is it will be constant. As per the second question is concerned, it is that it will increase with increase in temperature. And as per third question is concerned, it will decrease with increase in temperature. And the first question was asked in NEET 2026. The first question was, one of the part was from this NEET 2026. So it has got many interesting applications. The behavior of the resistance under different temperatures and variation of resistance with temperature for insulators, semiconductors, and conductors. So this is one of the important question. In case of any doubt, you can ask in the comment section. Thank you and have a nice day.